A concession stand makes 75 cents on each candy bar and 50 cents on each soda. On a typical Saturday, it sells between 25 and 100 candy bars and between 100 and 200 sodas. The total sales have never exceeded 300 sodas and candy bars. How many of each should they have to maximize the profit?
Okay, so linear programming problem.
Mm-hmm.
I need those numbers again. They earn 75 cents per candy bar, 50 cents per soda.
Mm-hmm.
That's their profit. And C has to be between what and what?
25 and 100.
And S has to be
100 and 200.
okay. And that's all the constraints?
Mm-hmm.
What is our profit function? Profit's equal to what?
Profit is equal to 75x
Or C. I'll just use C for candy. And
plus 50y.
Or
S.
S. Okay, so that's the function, the objective function that I want to maximize.
Okay.
Now, how I do it is by drawing my constraints and labeling the axis as candy and soda. And I know candy has to be between these two lines.
Mm-hmm.
And soda has to be between those two lines. So the area covered is that square right there. Our answer has to come in that area. And there are 4 vertices to that polygon. It doesn't matter whether it's a rectangle, a square, a triangle, a 5-sided figure. What we're going to do is we're going to find each vertice, plug it into our profit function. Whichever one gives us the highest answer, that's our answer. Okay, so it's probably one of either that one or that one, but it could be that one. It's not likely going to be that one, even though we'll want to test that. You see why it's not likely to be that one? You're not going to make your most profit when you're at the lower ends of these ranges. But it's unclear as to which of these other 3 vertices will be the maximum. Well, let's talk this vertice right here. What profit is made when I'm selling 25 candy bars and 200 sodas?
Uh-oh. So you'd have to do the math for that.
Yeah. And in other words, let's say we're going to call this P of X. Can't even call it P of X. I'd have to call it P of C comma S. It's going to be a function of that. And what I want to know is what is P of 25 comma 200? Well, if I plug it in, it's 18.5 plus 100. Hold on, let's see. 75 cents times 25. You have a calculator in your handy?
Mm.
Here, I got one. Usually don't need one, but that's 1875. So that would this one would be 1875 plus 100, or 11875. Okay, now let's check this vertice over there. That is P of 100, comma 200. What's that equal to? Clearly more, right?
Mm-hmm.
Well, 100
Equals 75.
75 plus 100, so that's 175. So that's our winning answer so far. But now I got to check that vertice, and there's no way that's going to be less, because it's the same value for S and a smaller, or it's the same value for C and a smaller value for S. But just so we do the problem properly, if I want to check P of 100, comma 100, well, that's going to be was the original equation. That'll be 75 plus 50. So that gives you $125. So now we can just compare each of those answers. And if I do check this vertice right here, in other words, P of 25, comma 100, that ends up giving me 68.75. So clearly the best solution is to sell 100 candy bars and 200 soda. That really is your most basic linear programming problem. They can come a whole lot harder than that.
Mm-hmm.
Usually they result in a rather odd-shaped figure. In other words, a lot of times when you draw your constraints, one of them will look like that, another one might look like that, another one might look like that, and you end up with this shaded area right there, and you got to figure out that vertex, that vertex, that vertex, and that vertex. You got to figure out the coordinates for all four vertexes, plug them into your objective function, whichever produces a minimum or a maximum, whichever one you're looking for is your answer. But that's the standard linear programming. And each of these lines that I've drawn here would represent a constraint. In your problem, the constraints were very straightforward. They were just vertical lines and horizontal lines. But in a harder problem, they might be lines with slope.
Okay.
Okay?
So the next one, hang on. This deals with imaginary numbers.
Okay.
Write the expression 5i over 2 plus 3i as a complex number in standard form.
All right. With imaginary numbers, it's very, very easy to add them. Very, very easy to subtract them. It's very, very easy to multiply them. The one task that's a little difficult is dividing, because you're not really going to divide any more than I'm not going to do division when I look at that. I'm going to rationalize the denominator to turn it into that. Okay? Same thing here. Mathematicians do not like an imaginary or a complex number in the denominator. So to get rid of it, I'm going to multiply top and bottom by the conjugate of this, always the conjugate. And that I'm multiplying by is 1. I'm allowed to multiply any fraction by the number 1 without changing its value. And what it's going to do, and what it's going to do is it's going to turn the denominator into a real number. What is 2 plus 3i times 2 minus 3i?
1.
Yeah.
0?
No. Let's do it piece by piece here. It's, you'll notice that's the difference of perfect squares factored. So the answer has to be 4 minus 9i squared. Right? In other words, if I do it by just foiling it, it's nice to recognize difference of perfect squares when it's in factored form, because you run into it a lot, and then it makes it much easier to put back together again. Okay, well, that's 4 minus 6i plus 6i minus 9i squared. Well, those cancel, so there's my 4 minus 9i squared, but now the secret is to convert I squared. What's I squared equal to?
-1.
So that becomes 13. I've made it real. And it's always going to be real. Whenever you multiply by the conjugate, the two middle terms with I always cancel one another out, and the I squared always turns real. Now, the top is 10I minus 15I squared. And so this whole thing turns into, that's minus 1, so 15 plus 10I, and that's not quite the final answer. In other words, A plus BI is in proper complex number format. So I would want to turn this into two fractions. 15 thirteenths plus 10 thirteenths I. Now I have it in A plus BI format. Okay. And like I said, that's the only one that's hard. Multiplying them, just use FOIL. Adding them, add the real parts, add the imaginary parts. Subtraction, same thing. So handling what would be called division is the only thing that's a little tricky. Just always remember you want to multiply that by the conjugate. What else you got?
If the domain and range for y equals 3x squared plus 5x minus 6.
Okay. Is that factor? Probably 3 and 2. No?
No.
Two and 3 don't do it. 6 and 1 don't do it. So I'm going to have to use the quadratic to solve for the zeros.
Okay.
However, if the only thing they want is domain and range, well, it's a quadratic that points up, right? It's going to look something like that. What's its domain?
Negative infinity to positive infinity.
Correct, all reals. The range is the only thing that's tough, and we would know the range if we knew that y value. Okay, so actually, rather than solving this, let's find out where its vertex is. Where is the x-coordinate of the vertex? What's the general formula for that?
I don't know.
It's the first half of the quadratic, minus b over 2a. That's only going to give me the x-coordinate, but that's still going to be the easiest way to answer this question. It's going to be minus 5 over 6. And now, what I really want is the y-coordinate, right?
So you sub in the negative 5 over 6 for all the x's?
Well, yes, exactly. So y, the range on y, or the measurement on y at the vertex is, I got to do this math. Whatever that number is the bottom end of the range. In other words, I know it's a parabola. The range is going to be from there to positive infinity with a bracket on the lower number, because it can be that number. And I don't honestly know whether it's going to be below the x-axis or above it. Looks like it might be a negative number. Yeah, it's definitely going to be negative. So it will be down here. But whatever that is, I don't think we should spend the time coming up with that specifically. That's just arithmetic that you can do in your calculator.
Mm-hmm.
Okay. And like I said, the range is going to be from whatever that number is to positive infinity, because it clearly can go to positive infinity on either side there. It just can't go below the vertex. Okay?
Okay.
Okay, what else you got? You got quite the range of problems today.
This is a review for a CPA.
Ah, okay.
She told us that we have a CPA on Thursday and gave us this today.
Okay.
So, this one is just kind of like checking, but,
what do you mean?
Like, I just want to make sure I have this right and
okay.
I'm not just confused. But, like, given the following quadratic equation, y equals 3, parentheses x plus 5, and parentheses x minus 10.
Okay.
Find the vertex. So the vertex would just be negative 5, 10, right? No, it would be between
the
negative 5.
The x-intercepts would be at negative 5 and 10. Okay, so the quadratic, it's a parabola. It's going to go up, and the line of symmetry, which is where the vertex is going to lie, this point right there, is going to be halfway in between minus 5 and 10, which is at 2.5 is the x-coordinate. Do they want both coordinates on the vertex?
Mm-hmm.
Plug in 2.5 for x and solve for y.
Okay. Yeah.
So you have 3 times 7.5 times minus 7.5. Whatever that number is. And it's definitely a minus number for the y coordinate. Plus for the x, but minus for the y.
Okay.
Okay?
And then I have some more I wanted to go over with you tomorrow.
Okay.
It's more like some solve a system of equations and stuff.
Okay, that's fine. I like it when we do this kind of stuff. I mean, jump around in different areas. I think that's helpful for you.
Thank you.
You got any more you want to do tonight? We started a few minutes late. If you want to do another one, that's fine with me.
Okay, thank you. Okay, there's a bunch of completing the square stuff, but I know how to do that.
Okay.
So.
You sure you know how to do the hard ones?
Just more solving systems of equations that I know I can't do, or like solve the quadratic system and then check with your calculator, stuff like that. But like factor and solve. Oh, here's one.
Complete the square on this one right here. I just want to check and make sure you know how to do one thing. What's the first step in completing the square? factor out the 2.
That's what I'm doing.
Okay, in other words, you can only complete the square if you can get that first coefficient to be 1.
Yep.
So I haven't changed anything. Now what am I going to add here?
You're going to add, well, first you have to
Divide by
square
2.
that. So
Now
squaring
first you divide by 2.
and then you
square. So it's 3/4 squared or 9/16. Now here's the tricky part, and the reason I asked. What do I have to add to the other side of the equation to balance what I just wrote in there?
2 times 9/16.
Yeah, 2 times, not just 9/16, but 18/16.
Mm-hmm.
And then, of course, this becomes x plus 3/4 squared, and you end up with that. Okay.
And then you subtract the 4 and...
Well, you add those two numbers and divide by 2. And take the square root of both sides and so forth and so on.
Okay. Do we have time for one more, or do you have something after me?
No, I don't have a 4 o'clock, so go ahead.
Okay, factor and solve 6x cubed minus 14x squared plus 4x equals 0. So we factor out the x, right?
At least. In other words, you can't solve a cubic. You got to turn it into a quadratic. They haven't taught you how to solve cubics yet. So, in other words, if I put a number on the end of this, that's such a hard problem you can't imagine. You think the quadratic formula is tough. Solving cubics is like a nightmare. But as long as there's no constant, I can factor out a greatest common factor. What is the greatest common factor going to be?
X.
2x.
2x.
Yeah, make it as simple as possible because we still have to factor this quadratic.
Well, you could have factored it without taking out the 2 as well, couldn't you?
Well, I could have. I could have just factored an x out, and it would have stayed 6x squared minus 14x, but then that would have been much harder to factor. This is going to be easier to factor than if each of these numbers was twice as big. See what I'm saying?
Kind of.
Well, let's factor this, and I'll show you what I mean. This factors pretty easily.
Oh, 3x minus 2, x minus, or 3x minus 1, x minus 2.
Okay. Now, notice how much harder it is to factor this. If I wouldn't have pulled the 2 out and still had my original numbers, that becomes it's easy enough to do because we know the answer, but would you rather have to factor that or factor the one that has a 3 there? Because there's lots of factors of 6. There's only one set of factors for the number 3. So always take the greatest common factor out when you do it. It'll make the problem far easier.
Okay.
And once you get it factored into 3 factors, don't forget the 2x. In other words, my answer was, if I remember right, what was it? X minus 2. Okay, now what are your 3? There's 3 answers to this, and an awful lot of people forget this one. In other words, they would come up with x equal 1/3 for that, and x equal 2 for that, but they would completely leave that out. The other answer is x equals 0. Okay, don't forget that.
Yeah.
In other words, what I have here is the product of 3 things equals 0. So set all 3 things equal to 0 for your answer. And
Okay.
when you have a cubic, expect 3 answers. Just like when you have a quadratic, expect 2 answers. If you have a quartic, there's going to be 4
Expect
answers.
4.
Mm-hmm. Not
Yeah, you're just.
Not 100% of the time, but that's the most number of answers there can be, and that's how many there usually are.
No,
Sometimes
you're always gonna have 4 answers. Aren't the other ones, if you don't have 4 answers, they're imaginary?
no, but you can have one answer twice. In other words, maybe I come up with both my answers are x minus 2 times x minus 2 times 2x. So I really only end up with x equal 2 and x equals 0. But what happens is they call this 2 answers, or one answer with multiplicity of 2. So you always end up with the number of solutions that you're supposed to. It's just that some of them can be the same. And so you don't see 3 unique answers, you only see 2 or 1, whatever. But never can there be more than 3 if it's a cubic.
Okay.
All right. Good to go?
Yeah.
All right, Julie, I will talk to you tomorrow.
Okay, thank you.
You're welcome. Bye-bye.
Bye.